Welcome to this session where we're going to talk about the focal framework and a introduction to the physical implementation on a Microsoft SQL server. In today's sessions, we're going to learn about the split of data and metadata. We're going to learn about the physical table patterns. We're going to set up a physical model. We're going to learn about semantic implementation and how to expand your semantic model. We're going to do a walkthrough of one of the 8 SQLs that reside within the focal framework. We're going to load data into your data tables with the help of that SQL. We're going to create views on your data with the help of the method data model. To set some expectations, this is a very light implementation. It does not contain all the functionality to build a focal data warehouse. This introduction is about introduce a new way of thinking about data storage and show some of the focal functionality in a simplified way. So let's start. Data versus metadata. In the focal framework, the description and the understanding of what data that resides within the data model is within the metadata layer. The data model is a physical model which is ready to absorb any data you want to load, as long as you have described it in the semantic model. So if you want to add a new attribute to the data model, you will then add it first into the metadata model. Once that is done, you can load the data model with the new data for that attribute. There is a relationship between these two different layers in the architecture which we call a semantic key. So you can simply join between the data model and the metadata layer to understand the meaning of the data that resides in the data model. Now this might sound a little bit strange and abstract, and that is the reason why we are holding this presentation. Now let's move over to the physical table patterns. In the focal framework, there are a number of table patterns. These table patterns represents a way of storing data. They have some speciality within each and every one of these patterns. We are going to go through 3 of these patterns and 1 of the SQLs. To understand is that one of these patterns have their own SQLs aligned to them. These SQLs never changes in their logic. So you can build your data warehouse or your business data warehouse with the help of 8 SQLs. In this example that we're going to run today, we are going to look at 3 different table patterns. We're going to look at the X-type pattern and its SQL. That is the SQL we're going to do a walkthrough, and that's the SQL we're going to use to load data into the physical data model. We're also going to use the pattern focal and identifier, or IDFR as it's called. That SQL is the only SQL that loads 2 physical constructs at once. This SQL will not be looked at or used within this session. To go through the logic and give an understanding on how the identifier SQL works, that is going to be its own session. But with the help of these three table patterns, we're gonna build and implement two different focal implementations. We are gonna create a physical focal model for loans, and then we're gonna create a semantic metadata focal for attributes. And as you can see, there is a loan focal and a loan identifier. There is an attribute focal and an attribute identifier. And then we have used 4 instances of the type pattern to represent data for different descriptor concepts. Okay, let's start implementing the physical model that we have discussed in the previous slides. So first we're going to jump over to the database, and we're going to create a new database. We just add the database. We're going to call it focal demo. There's nothing special about it. We just add that so we have somewhere to play around. And then in this one, we will now add our focal tables. So just to show you with the ease you can do this, and since the structures are reusable and always looks the same, how you easily can do a find replace to set things up. So we go to the script area, we take the focal generic model. Now this is a piece of the full focal model. I mean the focal pattern, or each pattern has been assigned to its descriptor concept. So you can see here we have classification, which is called CL. We have CD. We have name. We have desk, description and definitions. And they all are using the type pattern. So all we need to do here is that let's say we're going to create the loan focal then. So let's just save this. It's the loan model. Save it, and we just replace the focal tag here with loan. Oh, you're doing the entire solution. That's not. So we go in here and we take current document, and then we do that. So 31 occurrences has been replaced. So with that done, I think we just implement it. So we have done that. We can save it, and then we can go and open just to show you once again, we do the generic model. You remember we were supposed to create a attribute as well, right? So we're gonna create here an attribute model. That was the attribute focal, right? So we're gonna use just a smaller wording. We just use ATR for attribute, and then we do replace 31, we implement it. So now if we look in our little focal demo database here, we have some tables. And the thing is that these tables, as explained before, doesn't really represent anything yet. There is generic columns that are ready to absorb any kind of data from an atomic context perspective. So they are now ready to be loaded with any data you want. But since focal is working somewhat differently than other models does, we need to go back to the presentation. So here we have implemented our first focals. We're all happy, and we can see the physical table doesn't represent any specific data. They can absorb any data. But to be able to load these tables, we need to set up the metadata model first. And we need to create our own semantic model to describe other models. And this is a place where everything gets turned upside down from what you normally are doing. And remember, we are doing things differently because we want to have a specific effect in our architecture. So let's say that we would do a logical model of attributes. So we want to say that we have an attribute has a name, right? Is a common name for the attribute itself. We want a definition of the attribute. We might also want to tell something about the attribute if it's a source attribute or if it's a business information model attribute. Well, what kind of model type does this attribute belongs to? So this is our little attribute model, right? So now we're going to take this semantic logical model and implement it into our physical attribute model. So let's go. So first thing we're going to do here is to open the demo script. So the demo focal framework. So step one is that we're going to have some kind of key sequence to be able to create keys for things. So now we're going to create identities for our new semantic attributes. So you can see over here we have sort of designated them to mean something. So we have a common name which identifies as SEM1, semantic 1. Model type is SEM2. Common definition is SEM3. These are going to be added into our attribute identifier table and to our attribute focal. So this is just creating instances which we can use to describe things. But first, in this case, we only have some identifiers and some keys, right? So it's SEM1, SEM2, SEM3 is identifier, and they have their surrogate keys over here, the attribute key for each one of them, and they also resides in the attribute focal. But we don't understand what these keys means or what this identifier means, right? So we need to give them a name. So instead of having a physical implemented name such as common definition as a column, we instead create a name in our metadata model. So we give them a name. So now each of these attributes, SEM1 or SEM1, SEM2, SEM3 here, has been given their names, common name, model type, and common definition. We also want to have a definition / description on them, and we also want to designate into what model type they belong to. So we say they belong to a semantic model. And here we have a definition / description of these attributes. So if I now would look at the common name of my attributes, you could see here that the common name for that key is common name. This is where the head hurts, right? Because it's like the hen and the egg. We are using ourselves to describe ourselves. And this is just a setup process of the metadata model, but I would like to show you anyway. So here's the common name for this key is model type. And for this key, the common name is common definition. And you can see this type key here is the same as that one, right? Because the type key is what represents the name. So this key represents that what I have in the column is represented by a common name. And this is the same thing for every one of these. So here you have their common definitions for each and every attribute. And here we can see also what their model type is. And if we create some more advanced views on this, we can get some more information. I will try to use these views to explain even further how this works. So if we look now at the description here, or a definition, remember the semantic attribute that we had had this key. This is the identity of the attribute. Its name is common name, right? And we are using another attribute, which is common definition, to set the definition of that key. So all of this resides in the metadata model. And when you do it like this, it might feel very strange, but this is just trying to clarify what's happening. So we have a semantic key, which name is common name, and then we say that its model type is semantic. If you look at name, it looks even stranger because it's name to name. This is attribute. The semantic attribute name is common name, and it's set by common name. So in this case, it looks back. So how did it get that name? Well, by having model type as its common name. And we're going to show you later how you can add different names on the same attribute. But this is just to show you how we set up the metadata model. We create a semantic model in the metadata model, and then we start using it by describing itself for certain areas, and then we're going to use that model to describe other models. So we are going to go back to the presentation here. So we have now implemented this model. Remember, we created attribute, instances of attribute, one for model type, one for common name, and one for common definition. And then we used themselves to describe themselves. That's where your head starts to hurt. But don't focus too much on that. Let's move on. So this is the basis of how the focal implementation works. You can add models into the semantic layer by representing them as rows. You can enrich and expand your model by adding new attributes as rows and use them to represent data. So let us now use the semantic attribute model, right, to represent the business model's attributes. So this is a representation of loan where we have a loan amount with its currency and we have a risk category of the loan. So let's start to implement this in the metadata layer. This model, this loan model, which is a business model, will now get implemented into our metadata layer. So first of all, we set these instances. I just need to explain that this is not normally how it works, but this is just to not use all of the SQLs, all the 8 SQLs to do this. We're taking it one step at a time. So this is a simplified way to do it. And this is just to show you what we're doing. So we're creating an instance for each of these attributes. We have the risk category, the loan amount, and the loan currency in our loan model. So we create an attribute key for each one of these. There we go. And now they are only keys in there, right? But we need to give them name. Okay, so let's see if we start to understand this at this point. So here we have BIM1, right? And the BIM1, the identifier BIM1 of the attribute BIM1 is a representative of risk category, business model attribute number 1, right? And here in this SQL, we pick up the BIM1, the key that we created here, right? So we created an attribute key for BIM1. And we just picking it up here from our attribute identifier table, picks up the key because that is the key that we're gonna describe. Now let's move on to the type key. Okay, the type key is representative of what we want to describe about that key. So SEM1 was common name, right? It stood for common name. So it picks up the attribute key that represents common name, and it's going to be the one that represents the type key. And then we set their values. So the common name of this key is a risk category. And for this key, the common name is a loan amount. We execute that. And we do the same thing. For a common definition, we are using the attribute SEM3. If you remember, that was the identifier of the common definition. And for the attribute BIM1, which was risk category, we are going to set its common definition here, represents a specific risk category that a loan belongs to. And let's add that data into our metadata model. And then we want to classify them to which model type they belong to. So remember, SEM2 was representative of model type. This is the attribute instance that we want to designate a specific model type to. And we say that the model type for BIM1 is business. So here we go. For each and every of these attributes belongs to the same category of model types, the business model. And then we add that data into our metadata layer. Now we create some views here, just to go through the same thing as we did last time. And this time it might make more sense because now it's not circular. So if we go in here, we can now see that this key, this business attribute key, has its name risk category set by the semantic attribute common name. So the common name of that key is loan amount. The common name for that key is loan currency. And if you go by description and definition, you can see that this business attribute is risk category. Its common definition is represents the specific risk category that a loan belongs to. This business key has its name loan amount, and its common definition for loan amount is the monetary amount that agreed upon with a counterpart. So by this, we can now describe other models with the first model we created, right? We created a model that had three attributes in it. We had its common name, the common definition, and model type. Now we're using those attributes to describe another model. So the business attribute for risk category is designated to be the model type of business. It belongs to the business model type, you can say also. Loan amount and loan currency as well. Okay. So by that, we have now implemented this model in the metadata model. We use the first model, the semantic, the attribute model, to represent another model. And we can do this for any model, and you can expand it how much you like. And further on in the presentation, we will look into that, how to expand and use the metadata to describe different things about your different models. So, but is these the scripts? you normally use. No, normally you have ETL, ELT jobs that populates the metadata model, or a visual interface against the metadata model with the ability to look at it and add, change, and delete things in it. And sometimes you even have both. But the thing is, you do not normally sit there and add an attribute at a time with a script. It's normally you have Excel sheets or something else, or a model, a management tool where you can extract the model from, and then you just add it into the metadata model with help of an ETL ELT job. But let's continue. Now, you remember we created the attribute focal, and now we have added a lot of information into the attribute focal. We have added the attribute semantic model, and then we use that semantic model to also add business attributes from the business model. And now we're going to use those business attributes to load our physical loan model. And there is a lot of small sheets we're doing here because we do not have a fully implemented semantic area, of course, and we're not using any code framework, and we're just sitting and running some scripts here. But this exercise is just to simplify and explain some of the basic functionality and not get drowned by the full functionality of the focal framework. Let's jump back to the scripts, shall we? So if we want to add source data, but we want to integrate that source data, first of all, we need some source data, right? So the first step is that we create and load a source table for loans. So we're going to open the script, create source table, and run it. That seems like something I can handle. Maybe open and create source table, right? So here we create a table and we add some data in it, yada yada. So there we have 4 loans here, loan numbers. We have something called RCAT 1132, something AMT, and some AMT-KUR, some S-date, E-date, LPERD. There's something from the source that we have gotten here, right? So normally what we do then is that you have a source, it contains data, it has its own vocabulary, it has its own way of storing data, but we want to store the data in a common reusable fashion. So we want to integrate the data. And to do that, we need to map the source to the target. And we're not going to do that exercise as such here, but we are going to create the mapping, the pre-created mapping we have here in the script. So we have the semantic integration table. This is normally a view in a focal implementation. It's a view against the metadata layer. The metadata layer does also contain the instructions for integration that the code is going to use to integrate the data generically. So let's just create and implement this then. So the result here, we can see some rows. It looks like we have an AMT is going to go in the source. The source table is EBA loan. The source attributes is AMT, and it's going to be loaded as a loan amount, right? And there is some more information here. Here we have something interesting. We say RCAT is going to be loan risk category in the risk category area. And here's something funny, right? So if they send a 1, it should be an A on the target side. That means that the local source has one way of categorizing the risk of a loan. But from a common view in the business, they use A, B, C as risk categories. So we want to translate the source values into the common values, right? And this has been done when we've done the mapping. So this information we have at our fingertips, so to speak. So that was step 14 here, right? We did the integration view. Now, step 15 here. Once again, we're not using the true IDFR logic. We will have another session in near future where we will discuss and show you the IDFR logic as well as we're doing here when we are looking at the loading pattern and the logic of type pattern, the type pattern used to load data into our descriptors. But first here, we're going to need to add 4 loans, right? So this is where we create the loan key. So we quickly load that. Now, this is where we have created, this is normal loading pattern, right? You are creating your keys in the focal, or if you would be in Data Vault in a hub, and then you dress that key up with descriptive information. And this is what we're going to do. Because if we do a select now, loan CD table, which is conditions on a loan, it's going to be totally empty. And there is a type key here, right? Is a loan key, type key. There are some dates. There's some status on the row. There's some start timestamp, end timestamp, some value string, unit to measure type, and then there are some metadata, batch data oriented keys down here. So as you can see, nothing has been decided yet what is going to end up in this table from a physical perspective. But now we're going to load it with some data. So we are going to first of all go to another step here. We are going to open the type SQL explanation. I'm going to do an overview of the type SQL when it's not sort of fixed for a specific implementation. This is the raw SQL, so to speak. And I'm going to quickly talk about it, about what it stands for and how it works. So we have different areas in it. And remember, this is not built, this raw SQL is not built to be the most efficient or the most performance oriented one. It's built to be explaining the functionality and modular, to give a modular understanding of what's happening within this SQL. So the first part we call a reader. This is where we pick up the data from the source. Now, readers can look differently depending on what kind of source they are acting against. But the main thing is that you, in the end, will end up with this structure. Independently, if you have a lot of other things happening before here, this is the output of the reader, always, for a type SQL. Remember, this is output for a type SQL, for the type pattern. Other patterns have other outputs from the reader. That's why we have around 7-8 SQLs. The next part is what we call integration. Here we are picking up different keys. In this place, we only have the identifier of the object or the instance of data. Down here, we pick up its key. So we pick up the key of that. This will be replaced, this parameter will be replaced with the loan table. So you will pick up different keys and do certain kinds of integrations here. And this is repeatable all the time, independent of what data you're going to enter. And then we pick up the target data, right? We pick up the data from the target table, pick up its latest row, because we're going to do a delta check to see has there been any changes on the data that we have received and what we have in the target. And this has also been split up in 2 different areas just to make it easier to understand what we're doing. In this case, we are only showing the different scenarios. So you have the new scenario. This is a row we haven't seen before. This is a delete. We want to delete it, soft delete it. Here we have no change. We have another no change, and we have a change. So there is always the new, change, delete, no change. The 4 scenarios of delta checks. So this is done here. So we are setting a flag. That flag is then used to pick up the right data. So all of this can be incorporated in other kinds of solutions, so to speak, but this is just to break it out in different modular fashions to show you each and every step of the logic. And in the end, we do an insert in a table with the data that has had no change on it. That's it. It's not harder than that. So from a high level perspective, we have a reader, we have an integration, we have a target, we have a true delta, we have a delta check, delta, true delta area, and then we do an insert. And this can load any data from a type pattern for a type pattern implementation. So let's go and do that. So we're gonna open up the load type pattern. And in this case, I have just done a simple exec on Microsoft. So it's a lot of things here. It's just incorporated, and we're going to add, and we have a bunch of variables here that we're going to populate into this SQL and execute it. And this is all the parameters in this case that we are using, right? All of them will not be used because some of them will be null, others will be set. And how do I know which one will be set and which one will I use? Well, that is the next step. So remember we created the mapping, right? So we created the integration view, which told us which source data would populate and how it should be populated into the common model. And this little SQL reads that view and creates your parameters or variables or whatever you like to call them. So in the first case, we're going to look at the loan amount. As you can see then, just because in this case we are doing this as a variable, setting variables in Microsoft, this is how the parameters, the set parameters look like. You can design this to fit anything. If you have an Informatica, you can just fix it. So instead of saying that, it will be $, whatever. So whatever tool you use is just change how you want to name your parameters, right? So this is just showing you the concept, the idea. So by just having the mapping, this one can automatically then create the parameters for integration. So we just copy that, we go back here and we paste our parameters into the area here. So some of these will override some of these, right? And first of all, we're going to run this without doing an insert, because we're just going to check the result of the SQL. So let's run this then. So here you can see, here we have the loan keys that we created. Well, there were 4 loans, right? And this type key is the one that represents loan amount. And here you can see the loan amount and its currency. So it has now loaded. It hasn't yet loaded. We will load it. We just check the data first. So through the true delta and every step and integration of all the data, we came up with this result. So we now load our table. So if we now check we can see that here it is, right? So we have loaded this with the help of this type SQL, with the help of these parameters that we could generate just from the mapping information. Let's remove these, right? So, but if I want to load the loan CL then, the loan CL table, we had some risk category, right, that belongs to the, was seen as a classification. And this table is empty as well. But since it follows the type pattern, we can use the type SQL to load it. So let's look at this then. Now, this is that one. Let's generate some parameters instead. So instead of having the loan amount, we then take risk category, right? There we go. And let's see what variables we get out from that. So here's another bunch of variables dependent, remember, on this one. How is this? Risk category. Here we have the risk category. How is that integrated? And then we have all the information here about how to implement the risk category. And this is done through doing the mapping from source to target. And in the focal framework, we have templates for and processes for how you should think and how you do a mapping to help you in your work of integrating data into your data warehouse. So, but the result of that, running this SQL, is these parameters, right? So we didn't change this SQL anywhere, right? It's still the same SQL. On this data, it was the same data. We just position this was the loan amount. This is the risk category mapping. And so we haven't changed anything. It's the same data. It was the same SQL to pick up the parameters. The only thing we said, instead of loan amount, we're now going to check risk category. So instead of giving me the parameters or variables for loan amount, we told it just give us for risk category, and we got this. So now this is the same SQL, right? It's the same SQL. Nothing has changed. It's just new parameters. So let's check here. So we don't want to insert that directly. We want to look at it. So we run that. And do you remember that we had a domain value mapping that said if you have a 1 on the source, it should be an A. And if you have a 2, it should be a B. And if you have a 3, it should be a C. So this code has now semantically on a value level integrated the data just by creating the parameters or the variables based on the mapping, reading the mapping with the help of the SQL, and translating the data. And you can see here the type key is different than was in the loan table, because this one represents risk category. The other one represented loan amount. So you can now see if we implement this, if we run this, and then we check our loan CL that was empty before, we have now implemented the risk category for these loans. And this is without touching anything in the tables, without changing the SQLs anywhere. We have just reused the structures and reused the logic. And this is the power of Focal. You can create one of these jobs. This is a type SQL. I can load any type pattern driven by what we have done in our mapping work between source and target. I don't need to change the SQL. I want a new attribute. Do the mapping. And you can add it into your data. There is no change. There is no structural change. There is non-destructive change. That is for certain. But we don't have any structural change either. and we don't need to generate new tables. We don't need to generate new code because it is the same all the time. So by have done this, we have now loaded the loan CL and the loan CD table. Now let's create the view up on this, because if we go back here when we looked at this, it doesn't make much sense, does it? We have a loan key. Okay, we get that. That's an instance of a loan. But what the heck does that stand for? No one knows. It's just a number. I don't know what that means. So let's create now using our what? Yes, the metadata layer to help us translate this data. So once again, we're not changing anything as such. We have these views, but these views, once they are created, is generically reusable for this. So normally you don't access data directly on the physical tables. You normally read it through the view to have an easier understanding of the data. So now looking at the loan through the view instead, we can see it says loan amount. Loan amount is the name of the attribute, and we have 3,000 euros as a loan amount according to ISO currency code. And in the loan CL, we can see that, well, it's a risk category B, risk category A, risk category A, risk category C for each of these loans. So we can use the metadata layer to translate those keys on the fly. And by that, you don't have to be so afraid that you would not understand what's in your physical tables, even if the physical tables themselves may look a little bit scary. Okay. So let's go back to the presentation, right? So now we have loaded. We have loaded some data and we are happy. Now, next scenario. Let's expand our attribute semantic model. We get the requirement to classify our business attribute if they are private information, PI, or non-private information, non-PI. And we think like this, we're gonna add a new attribute into our logical semantical model, right? Because we want to have an attribute to describe our business attributes. So looking down here, you can see that we have GDPR class. That's what we call it. And let's hop back to our little demo. So once again, first we're going to create an instance for the GDPR class. We need to create an attribute key, an attribute instance. This one has its identifier SEM4. You can come up with anything you want. This is just a demo. So we add that row into the focal and into the attribute identifier. So, but we still want a name on it, right? So the SEM4, remember, that's GDPR class. And we want to set a common name for it, which would be GDPR class. So once again, we're doing all of these things again. We're giving it its definition, and we're giving what model does it belong to. So we do that again. So we have added those. Now look at these old views we had, right? All of a sudden they pick up something more. Something has been added into our model. We have GDPR class all of a sudden. So now we can use GDPR class to describe other models. Well, that's interesting. Okay. So we are going to have to put these attributes, these business attributes, we're going to have to set their GDPR class on private information. And the decision by the business is that risk category should be classified as private information. Don't ask me why, but that's what they came up with. But loan amount and loan currency would be seen as non-private information. Okay, whatever you say, business, let's add that. So here we have BIM 1, BIM 2, and BIM 3. That was the three different attributes, right? Business attributes. It was risk category, loan amount, and loan currency. Now we're going to set their GDPR class. This is a representation of a GDPR class, right? This SEM4, we created it up here. We're now using it to describe those keys. And we're setting that BIM1, right, risk category, is private information. The other two is non-private. Okay, so we add those. So now we have described our model even more. So if we look at the classification view on the BIM area, we can now see that this attribute, which is a risk category, has GDPR class PI. The same attribute, risk category, has model type business. And you can see how it's been added into our data. So we are describing now risk category with two different classifications. But we haven't changed anything, right? We haven't changed anything in the model. There is no new tables. There is no new columns. It is the same structures. So let's now create some GDPR views on this. And what these views does is that they will check if you are private information classified, you will not be allowed to see the data. You will then see a lot of excess. So if it is PI information, show excess. Otherwise, show the value. Right? So we have created these. Remember, we haven't changed anything. We're just using our metadata model to represent data. So if we look at the CD table here, it's a loan amount, right? And the currency is here and the value is here. Everything is fine. We can see everything. It's not a problem. There is no GDPR private information here. Everyone is happy. But how about those risk categories? Let's look at those. What? Am I not allowed to see these? Okay, so I know that this one has a risk category, but what it is, I can't see because it's private information. And it seems that I'm only allowed to see data through these GDPR classified views because I don't have the right to see the data without the GDPR classification on them. So, but remember, I haven't done anything. I just added a row. I classified some data in the metadata layer, and all of a sudden, I can use these to set rules upon how to look at data. Who can see what? You can set rules on how to access data. You can do all kinds of things without changing anything in the architecture. Just use the metadata layer forever what you want. So that's funny, right? So now we have GDPR classified our model. Now let's go back to the presentation, right? So we added the GDPR clause, we classified our business attribute, and then we're able to use that when we're going to show the data. So let's continue. And we're going to keep expanding our semantic model to have even more possibilities to describe the data. In this case, the finance department disagree on the naming of the business attributes. That means that they do not agree that something should be called a risk category. It should be called something else. In their mind, it should be called financial exposure. That's what they call it. And they want to see data in that fashion. Now, there is, of course, different tools out there that you can use to have this sort of translation of it. Or you can hard translate it into a normal view. But since we have the metadata layer and a simple join between these, we can describe data from different perspectives. So in this case, we're going to add a new attribute into the semantic model, which we will call the financial process name. And this attribute will hold the financial process, what they think the attribute should be called. So let's do that. Okay, so we will, as always, need to create an instance, a key for that attribute, the financial process name. And then, as always, we're going to set the name of the financial process name, we describe itself, so to speak, say what is its definition and what model it belongs to. So we do that. And now we can use that to describe another model. Let's look in our views here, and we can see that something has been added. We have a financial process name now, which we have a name on, we have a definition of that, and we can also see what model it belongs to. So now we're going to take our business attribute and give them new names. Remember, the attribute is just represented by a key. So we can describe that key from multiple different perspectives. In this case, we're going to do it for the financial process view. So this was the risk category, loan amount, and loan currency. Now we're going to use our new attribute, the financial process name, and set new names on them. We're going to call it financial exposure, lending, and currency. So now that is done. Now we're going to create views that translate the type key into the financial process name. You remember, we had views that took the type key and instead of showing the key, we show the name of the attribute. So in that case, in the old views, we showed the name accordingly to the common name. But now we're going to show the name accordingly to the financial process. So we just create a view here that if you want to look at the data with the financial process vocabulary, you use these views instead. So you can see here now in the CD, instead of loan amount, it says lending. And in the classification table, you can see that instead of saying risk category, it says financial exposure. So you can do a lot of things in the metadata layer without touching the data or changing any structures or changing any code. The most thing you need to do is use it. And that's normally done through a view where you can then translate your data or show your data or add rules upon your data as we did with the GDPR clause. But we don't need to touch the data. We don't need to change any structures. We just use that relationship that we have between the metadata layer and the data layer, which is the type key that points up or points down, whatever you from what point where you're standing, into the data or from the data up to the metadata, and you can use that generically to do all kinds of things with the data. So, as a little wrap up, I hope that you are starting to see the possibilities in the focal framework after this. And remember, this is not a true implementation of the focal framework. It's a very light one. With a full implementation, even more possibilities open up. And maybe think about it, because we have looked at one of the SQLs and the functionality within it, and we have looked at the metadata layer and how it relates to the data underneath, and you can do all kinds of things with the data through the metadata layer. And to implement this kind of data warehouse, the basis is 8 SQLs that will load your data tables with the help of the metadata layer. And you can implement these SQLs in any tool that can use variables or parameters to execute their transformation logic. Well, with that said, I hope you have enjoyed the journey into the focal country, and that is the end. Goodbye.